Welcome to the practice problems for 2.4 combining polynomials. Okay, here are two expressions. Okay, so Andre makes a statement. So now let's talk about what a real number is. A real number, the real number system, and you can go look this up on the internet. Real numbers contain rational and irrational numbers. Yeah, what's an irrational number? Irrational numbers. Numbers like e, numbers like pi, numbers like the roots of non-perfect numbers, like the square root of 5, like the cube root of 7. These are irrational. Rational numbers are any fraction that can be a decimal. So let's say 2/6, which is really 1/3. 9/1, that's rational. So these are rational numbers. All right, why did I put a sign out? They can be positive or negative. Any decimal, 0.302, whether it's terminating or not. All right. Rational numbers also include integers. Integers go from negative whatever to positive infinity in whole amounts. So real rational numbers, you got rational, you got integers, you got whole numbers. Whole numbers, technically, mathematically, definition, start at 0 and increase in whole number amounts all the way up to positive infinity. And then you got what's called counting numbers or natural numbers. Natural numbers start at 1 and go to positive infinity in whole amounts. So when we say real numbers, we can have any of these numbers. So you can put any real number as a coefficient. That is true. You can put pi as a number. For polynomials, a polynomial must have a whole number. Must be whole. By the mathematical definition of whole, it must be a positive integer. It can be 0 because 6 technically is a polynomial. It's a monomial, one-term polynomial. So this works. So you have to think about the entire number system. And in Unit 3, we're going to learn about another number system. Okay, so looking at this one. When you multiply two integers, you get an integer out. Well, how do I know this? Well, 3 times 3 is 9. 2 times -4 is -8. -5 times 1 is -5. And -7 times -8 is positive 56. So 2 of them are positive, 2 of them are negative. So there you go. Okay, so let's look at this problem right here. We have a plus in between the parentheses or the groups. We have a monomial added to a binomial. And because we're adding, we use the combining like terms. X squared is by itself, so we're just going to write x squared. There's no other x squared term. Okay. Now, 5x is like -4x. Don't forget to put the sign with it. So 5 minus, they both have x to the first power. We subtract them. 5 minus 4 gives us positive 1. So we get x squared plus 1x. Mathematicians are lazy. So this is what you will see on standardized tests. If you want to write the 1 in there to make yourself feel good, write it in there, but you will not see this on a standardized test, so be careful. All right, looking at the next one, we have a plus, and then now we got a pair of terms that are like x squared is like x squared, and -x is like -x. So we don't see a 1 in there. Just write a 1 in there. It's not going to hurt you to write a 1 in front of the x. So the sign in between them is positive or add. 7 plus 4 makes 11, x squared. Negative 2 plus negative 1, same signs, add, negative 3x. Okay, so here's a negative sign out in front of the thing. When you have a negative outside, you have to distribute the negative to every term. Before I do anything, I want to distribute the negative. So I'm going to write negative 3x squared minus x minus 9. And so once I group my like terms together, I see negative 8x is like negative 3x squared. X and negative x are the same, and negative 9 is not like anything else. So negative 8 plus negative 3 is negative 11x squared. X minus x is 0, and we're just left with negative 9. So this comes down to fewer terms. Okay, finally, we get a 2x cubed. We get a plus 7x cubed. We get a negative x squared and a positive x squared because the plus is in the middle. If you don't want to forget, put a 1 in front of it so you keep your integers straight when you add and subtract. And then so here we go. 2x cubed plus 7x cubed is 9x cubed. Negative 1 plus 5 is plus 4x squared minus x. Okay, this goes back to an earlier lesson. So degree. Degree equals 5. The leading coefficient is 2. And the constant is negative 6. Be careful about them negatives. The sign in front of the term goes with the term. Okay, this is written in proper order. Our degree is 3. Our leading coefficient is 1. And our constant is 2. Positive 2 or just 2. And finally, negative 4x cubed. Look for the highest term. It doesn't matter where it is. This one is not written in order. So our degree is 3. Our leading coefficient is negative 4 because the sign in front of the term goes with the term. And our constant is 5.4. Okay, which point is a relative minimum? So now be careful with this one. A is the relative minimum because it has points on either side that are higher than it. You would have picked B, but that means you compared it to the other terms. The problem with B is not here. It's not at the lowest point. There's nothing higher on the right side, directly on the right side than B. There's a point lower than it. Then it gets higher. Okay, again, I like using the distribution arrows. No sign in between a group of terms means multiply. So distribute. Take the time to draw your arrows so that you remember when you do 2 terms times 2 terms, you should get 4 terms out. X times x is x squared. X times negative 3 is negative 3x. 5 times x is 5x. The sign in front of the term goes with the term. 5 times negative 3 is negative 15, giving us x squared plus 2x minus 15. Okay, again, same thing with the second one. Distribute and distribute and distribute and distribute. And we'll get 6x squared minus 24x. We will get negative 4x plus 16. Middle terms combined, giving us 6x squared minus 28x plus 16. Okay, so after this lesson, we're dealing with combining polynomials. We should have a quiz. So look out for that.